Hello everyone. In this video, we will see about forward kinematics of planar manipulators. So you have two approaches. One is systematic approach and other one is geometric approach. So here first we will see about geometric approach. So first, before going to that, what is forward kinematics? So we know that joint space coordinates are given, are known, and we have to find the task space variables, that is the Cartesian coordinates needs to be found. Okay, so as I said earlier, there are two methods for computing this forward or direct kinematics. So one is geometric method and the other one is systematic approach. Okay, so geometric approach, by inspection we will be finding the task space coordinates. Okay, and second method is systematic approach. So here we have to assign frames to the robot links and you will be using homogeneous transformation matrices. Okay, so in this lecture we will see only about geometric method. So first, consider this example as planar RR robot, that is it has 2 degree of freedom. 2 degree of freedom planar RR robot. By using direct kinematics, we have to find the task space coordinates. Okay, so consider this as the planar RR robot. Here we have assigned the links as L1 and L2. So two links are there. Here we need to find the task space coordinates or variables as x and y, that is the position and orientation needs to be found out, okay, for this planar RR robot. So first, this is by inspection. Geometric method is by inspection we need to find. So first, for that, assign the axis. So this consider this as x and y axis, and the angle for the link L1 between the base and link L1 is considering this as theta 1. Everything by inspection and assumption. Okay, and by projecting this, we know that if this is a link L1 and the angle is theta 1, so obviously here the adjacent side along the x-axis will be L1 cos theta 1. Okay. Similarly, on the other side, opposite side in y-axis, it will be L1 sin theta 1. Next, considering the second link and the angle is theta 2. Okay, so by projection, by inspection method, now the adjacent side for this along the x-axis will be L1, L2 cos of the angle will be theta 1 plus theta 2. Okay. Next, the opposite side link is here L2 sine of theta 1 plus theta 2. Okay, now we have to find the position and orientation of this. So position, that is x and y. Okay, so axis we have seen that it has L1 cos theta 1 plus L2 cos of theta 1 plus theta 2. Okay, this is your position of the end effector as xy. So x is, as I've said, and similarly y is L1 sin theta 1 plus L2 sin theta of theta 1 plus theta 2. Okay, and this is the position of the end effector. Now the orientation of the end effector is theta 1 and theta 2. Okay, so theta 1 plus theta 2, that is I am considering this as psi. Okay, so this is the position and orientation of the end effector for 2 degree of freedom planar RR robot. Okay, next consider another example, 3 degree of freedom planar RRR robot. Okay, so by geometric approach of direct kinematics or forward kinematics we call it as. So this is the triple R configuration. For this, L1, L2, L3 are the 3 links, and theta 1, theta 2, theta 3 are the joint angles, okay, named respectively, and it has two axes, x and y axis. So we have to find the position and orientation of this by inspection. Okay, so first triple R configuration, whatever is given, considering this, just projecting this x and y axis, and then for each joint, now you have to consider the adjacent side as L1 cos theta 1. Okay, similarly on the opposite side it is L1 sin theta 1. And next, again projecting on the second joint, so you will have L2 cos of theta 1 plus theta 2. Similarly, L2 sin of theta 1 plus theta 2. Next, the end effector. Now considering this projection by inspection method, so here similarly we will get L3. The link is L3. So cos of theta 1 plus theta 2 plus theta 3. All the angles. Similarly on the other side it is L3 sin of theta 1 plus theta 2 plus theta 3. So from this obviously we will get the position of the end effector. Okay. X and y is axis. The x-axis, what are the parameters we have got, and y-axis, what are the parameters we have got. Okay. And the orientation of this is here three angles, theta 1 plus theta 2 plus theta 3. Okay, that is considered as psi here. Okay, so this is the position and orientation of the end effector for 3 degree of freedom planar RRR robot. Okay. Next, same thing, considering other example as 4 degree of freedom. Okay, RRPR manipulator. For this, by geometric approach, so consider this as an example. Okay, 4 degree of freedom. For this, we need by projection or by inspection or by geometric approach, we have to find the position and orientation. Here position and orientation is 3 axes, x, y and z we have to find. Okay, but this problem is complex one. Okay, by inspection method it is tedious to find the position and orientation. That is why we are going for the other approach called as systematic approach. Okay, what we have seen as earlier. So there are two methods for this forward kinematics to find, is the one is geometric approach and other one is the systematic approach. Okay, so systematic for this, because of this complex problems cannot be solved, it is a tedious one to solve these complex problems, so that is why we are going for the systematic approach. Okay, that we will see in the next lecture. Okay, so thank you.